Cure your globitis this week. Thank you.
We got one!
Ladies and gentlemen, it's the Globebusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
And now, here's your host.
And welcome everybody to Globebusters Science This. I am your host, Bob Xanadude60, and now we are back with another Sunday show for you today. And this will be our absolute last Sunday show that we will be splitting on between Rockfin and YouTube. I was going to make it last week, but because of the fact we ran into a little trouble last week and I wasn't feeling so great, we wound up doing it on Sunday. So I decided I would go ahead and move it up for everybody once, because, you know, I don't want anybody to get gypped out of anything, that's for sure. So anyway, today we're going to be covering a couple different things. There is a globe earther that I have been having some dialogue with, and his channel is called I Can Science That. Okay. And this gentleman apparently has advanced degrees in aerospace and aeronautical engineering. And we have talked, he and I have talked before, and, you know, I don't have to tell you that when we came out of our discussions with each other, I was looking at him like he was, you know, pure Dunning-Kruger, and he was looking at me like I was pure cognitive dissonance. But, you know, it's the same old story going, you know, either way. But he is a fairly nice guy, and he does seem to want to really try to answer this. But last night or yesterday, he came out with 2 videos, and the title of those basically is something about, let me pull them up here. It is called Dipping the Nose Part 1 and Part 2. Okay. So, and in this, he addresses the flat earthers claims, you know, where we say you cannot be flying on this without, you know, without dipping the nose. And yet every pilot will admit, except for one, that you have to dip the nose, or that you don't dip the nose, excuse me. That one pilot that says you do have to dip the nose is Wolfie 6020, but, you know, we've already dealt with him, and should it be necessary, we will go back to that video and deal with it again. But there are several things that were left entirely untouched and unsaid. And in fact, when I watched this thing, I watched it the first time last night, and even though I was not feeling the greatest in the world, I was laughing my butt off because I couldn't believe, you know, I was just looking at this going, he's got to be kidding me with what he's saying here. And, you know, I think you're probably going to see the same thing here. But in the interest of actually, you know, starting up a dialogue with these people, and I'm not saying I'm going to invite them onto the show or anything like that, but we'll kind of do a couple jabs back and forth and see exactly how this is responded to. Because, you know, in my opinion, he didn't answer anything. In fact, it sounded like a whole lot of doublespeak to me. And I have a lot of questions that I would love to have him answer. And he has, of course, requested those questions. And, you know, I think we ought to hit him with it full blast. And this, I think, because of the fact that, you know, we know that the Earth is flat, and he is so convinced that the Earth is not flat, you know, in my mind, the logical course of thinking and also sciencing this is going to take us right down the line and tell them point blank that what they are claiming is scientifically impossible. And I am so confident in that I wanted to start this ball rolling with everybody and see how that would work. So we'll see how that works today. So let's go ahead and introduce the panel, and then we'll kind of jump right into it. Up as always, first we have Jeran from Jeranism. How you doing today, Jeran?
Great, Bob. There we go. That's better. Doing great, Bob. Thanks. I'll figure out the mute button on here one time. Eventually.
Okay. Eventually.
Nope, just hot here in California and kind of miserable a little bit, but fighting through it.
Yeah, I know it's been really humid here as well. So I don't like the idea of air conditioning being cut off. I'll tell you that much, because it would be miserable if it did.
Oh God, yeah, that'd be dying. You used to live here in the armpit, so you know what it's like. It's not too much fun.
Yeah, that I did. Lived in Fresno in the San Joaquin Valley, and it gets absolutely. In fact, that's the reason I left there, because we had over a month of 100 degree days. It was crazy.
Yeah, it's nuts. Nobody leaves their house, and so you're right. The idea of the air conditioning going off would be catastrophic. So let's hope that doesn't happen.
Yep. All right. Beautiful. Okay. So let's go ahead and move on. We also have with us from down. No, he's not down under. He's up in Switzerland. Iro Landucci. How you doing today, Iro?
Great, Bob. Hello, everyone. Nice to be again in the show. Yeah, I don't know how exactly I am. I need to, I can use my eyes as a gyroscope, but they always tell me that I'm upside normal. I mean, normal orientation, man. So I think I live in a flat Earth. When the sky's up, the ground is down. So everything is good for me.
Excellent. Well, I'm glad to hear that. So
yes, I don't know how you live in the United States. Maybe you are 45 degrees, 22 degrees, something like that. Some Masonic degrees, maybe. I don't know.
Yeah, well, it's just our sideways way of looking at things, I guess. We manage.
Okay.
All right. Okay, next up we have the great Baldini from the Unintended Consequences channel. How are you doing today, Baldini?
Well, I'm here. How are you? Well, we're both kind of in the same boat, aren't we? Having some GI stuff. That's interesting. But yeah. But anyway, it's good to be here. Honestly, we were talking about the shape of where we're at. I was just thinking I've got some family. My dad's family is in Kansas, and that's been proven to be literally flatter than a pancake. So.
Yeah. Yeah. No kidding. And Florida is even flatter than Kansas. So.
In Kansas. Yeah.
Yep. Of course, it's mostly a swampland down there, but it sure is pretty. I got to give it that much.
Yeah, there is Florida Man. We'll cover that from time to time.
Oh, God.
And the Poppycock Report. So I got that going for us, which is nice. No, I got some very good friends in the community down there in Florida as well. No, it'll be interesting to see. I noticed that you're showing video here of Gyroscope, and I was thinking about the reason that, especially again, somebody would think that a pilot or a plane would turn is just the assumption. It begins with presumptions. The presumption that there is a globe, and therefore they just assume that gravity is causing a gyroscope to tip over, but the property of a gyroscope is rigidity in space. And
yes.
So there's no demonstrable way to demonstrate, to prove that, right? So gravity at the scale that they're talking about has never been proven. It's always theoretical. You can never prove anything attracting anything else. It just can't be demonstrated. It can only be assumed. So they assume that it's happening, and so to them, of course it's happening. We can't demonstrate it, and so we say, of course it's not happening. Anyway.
Yeah.
Interesting.
And the thing that, of course, makes it a conundrum is because, on one level, I personally agree with them, as far as that downward accelerative vector. But that is being brought to us by a cause that is entirely different than this mass attracting mass nonsense. And it surely has nothing to do with, planets orbiting around the sun or anything like that. I mean, that's just a point blank obfuscation of, a very simple phenomenon that happens here on Earth, and that, I think we've explained quite well in the electrostatic model. But, everybody needs to come to that.
It always gets to sort of an ad hoc explanation, right? So it always kind of fits whatever the situation is, right? You get this ad hoc situation, so it can either be mass attracting mass, and if that doesn't work, then it becomes bending of space-time. If that doesn't work, it's pulled toward the center of a sphere, right? So it's just kind of flexible. It's a magic, right? It's a magic potion. Put that shit on everything.
Yep, absolutely true. Oops, I got too many CC buttons on here. There we go. Okay. All right, cool. Well, let's go ahead and move on. And oh yes, Austin did make it. So glad to see that. So from Witsit Gets It, we have Austin Witsit. How you doing, Austin?
I'm doing good. How are you doing?
Doing fantabulous. Well, if I didn't feel like crap, I would be, but I'm at least brought up in spirit by the idea that we have some good material to, let's just say, I'm not going to say laugh at it, even though I really did laugh at it, but we're going to ask some really good questions. And I think that the questions that are going to be asked are simply not going to be able to be answered by this aerospace engineer, or will have to be obfuscated all the way through it. So that's what's kind of carrying me through today.
Let's do it.
All right, so cool. Well, first, before we do that, I noticed that Taboo Conspiracy put out a video that you did, apparently, and this is really cool. A summary of Flat Earth by Witsit Gets It, and I haven't watched the whole thing, but I assume it's on your channel. I found it on Taboo Conspiracy's channel, but can you kind of give an overall coverage of what you covered in this thing really quick for us?
Oh yeah, it's on Facebook, but I just had a bunch of people like trolling my page, so I thought one of them were genuine, so I just went on there and answered her like 101 questions. So I just randomly went live on Facebook for like 30 minutes answering Flat Earth 101 questions, like the stupid questions people ask, like can you fall off the edge, etc. And then I guess Dave put it on his app, and then Taboo mirrored it, so pretty cool.
Oh, that's awesome. Okay. And I'll definitely get around to watching it for sure. But I did kind of skim through parts of it, and you are, of course, on top of your game as always. And you did a fabulous job at it. I just, I don't know where you find all the time to do all the activism and all the stuff that you do, but you stay pretty busy out there.
Yeah, that's for sure. But it's cool. I like it.
Yep, for sure. Okay. All right. Well, I think that is everybody on the panel. Yes, it is. So, yeah, and Baldini, you're right. The reason that I have this gyroscope playing is because the gyroscope, of course, has always been a very key factor in this. And what I will say is that with these kind of ad hoc explanations that I Can Science that gave to us, never once did he mention anything about how these motions of the aircraft would be registered on the aircraft instrumentation. And this is the part that's going to do them in, guys. Because there is no way that they can sit there and say, well, yeah, we've got this motion going on, and we've got, 180 degrees or 360 degrees if we fly around the world, and that the aircraft instrumentation is not going to register it. It simply is. This particular video that I am watching now, or we're watching right now, is an old U.S. Navy video that talks about, gyroscopes and their claim to fame being rigidity in space. And it talks about the phenomenon of precession. Well, obviously, if you are flying around a globe, right, you will be changing the pitch of the aircraft. There's no doubt about that. And that pitch is registered very, very accurately by the gyroscopes, or I should say, if we were pitching, it would be, right? Because if we do any other maneuver, if we slightly push the nose down or slightly lift the nose up, that pitch change is absolutely registered without question on the gyroscope, right? Because that is its job, right? It creates the artificial horizon for us. It gives us our turn and slip indicators. These gyroscopes do. Artificial horizon, all this stuff, right? And all these are gyroscopic functions. Now, the problem is that, the ballers will sit there and make up excuses, and they'll say things like, oh, there's pendulous vanes in the gyro, which cause them not to register any pitch change, which of course is patently absurd. That is not the purpose of pendulous vanes at all. And not only that, we have taken gyroscopes without pendulous vanes that were simply nothing but a straight gyroscope that was motor driven. We've taken them on flights. I took one to Maui personally and set it up. I even told the captain what I was doing and explained the whole experiment to him. And when I got off in Maui and explained to him that the pitch had never changed, it didn't seem to surprise him. And it didn't surprise me either, because, I think he knew full well that we're on a flat earth and nothing like that would change. In addition to the gyroscopes, we also have these pieces of equipment that are mostly found in our phones, but you can buy them individually and away from the phone market. And actually you can get them a lot higher accuracy and a lot higher sensitivity. And these are accelerometers, and accelerometers will also measure pitch change, yaw change, roll changes, stuff like that. And ironically, when it comes down to, flying over the face of the earth, we never, ever, ever register any pitch change whatsoever on the gyroscopes, whether it is one with pendulous vanes, one without, one with Schuler tuning, one without. And of course, we did a show on the whole Schuler tuning aspect of gyroscopes several years ago. And I think the ballers kind of, walked away from that one, seeing that, that was a modification that was necessary, and you had to have computer aided navigation and all that. So the bottom line is, up until about 20, 30 years ago, we didn't necessarily have, these full blown computer systems that were flying aircraft that could be modified, to compensate for the curvature of the earth. Right. So that pretty much just discounts them right there. And like I said, we can certainly get away from that by, testing independent gyroscopes like I did, and like anybody can do. And we would actually invite the ballers to do the very same thing and to explain to us that if this pitch change is happening, like I Can Science This says that it is, then why is it not being registered on the gyroscope? That's going to be a tough one. That's going to be a real tough one. So, hey, I'm pulling for you, bud, but I know it's not possible. So it's just basically, I'm hoping that, maybe we can snap you out of it, and you will come to the conclusion that, and this is a tall order, but basically you're going to come to the conclusion that your training in aerospace engineering, which has taught you about this curvature, is going to be revealed to you as hugely fraudulent. And you're simply going to see that this cannot happen if you are intellectually honest, that is. But we'll see how that happens. So all the flat earth community is going to be watching on this, and so is the ball earth community. This is going to be great. And I think that for people that are outside of this community, watching this interchange is going to tell them volumes, because I am extremely confident that we do have all the evidence, and the ballers got nothing. Okay.
And at the risk of, I know that there are a certain, group of this community that says don't give them any ammunition, right? Don't give them their arguments. But at the risk of challenging that, but certainly cutting the thing off at the pass of the argument, because I've heard it before, right? Which is that, well, what the gyroscope and what the instrumentation is measuring is relative to the position on the ball, and so it wouldn't then demonstrate a change, right? Because you're just staying relative to that. That argument fails, however, in that it would have to be absolutely perfectly synchronous, absolutely, to not register anything, right? That argument fails completely. I mean, it would have to be, again, so perfectly synchronous that it wouldn't register anything. And so what we see is that it doesn't register any motion whatsoever, right? Other than the motion of the aircraft, only relative to the motion of the aircraft.
Yes.
And that's it. Right, so we don't see anything relative to the geometry. And speaking of, the geometry, physical geometry, this is almost a more simple thing. Just do. I mean, you can do it physically, or you can do it in your head. Just take a simple pin compass, and then think of what it would do at the equator. It wouldn't work if things work the way they say it does on a globe, or an oblate spheroid that's a little pear-shaped. It wouldn't work.
Yes, I agree.
A simple pin compass doesn't work in that orientation. Sorry.
Yes.
It's that simple. It's that straightforward.
Yes. And what you're going to find, Baldini, this is the crazy thing, is he's going to write all this off to the built-in and designed innate stability of the aircraft. Now, is that true? Oh, absolutely it is. Of course, aircraft are designed to be stable, right? Unless, of course, there is a specific aerodynamic in it where it needs to have a lot higher performance, like a fighter plane. when in that
But
particular
isn't
case.
it remarkable, Bob? Isn't it remarkable that all the instrumentation would show all the other relative motion of the aircraft?
Absolutely, it does.
Right. So, I mean, that's what I'm saying is that everything else is perfect relative to the actual motion of the aircraft, except for its relative motion in that aspect. In that respect, it's again, it's too much of the yeah, but. Right. It's like the Earth being, or the moon being 400 times smaller than the sun, but 400 times closer. Isn't that just remarkable?
Yeah, exactly. Yeah, it's, and that's the whole thing. I mean, these ad hoc explanations are really quite the bit over the top. So, like I said, he does at times seem to have a genuine desire to want to settle some of these subjects, and even though he has failed miserably on virtually everything he has addressed so far, even something that I thought would have been a slam dunk, and that would have been his interactions with Raichi 00000, he was unable to even pull that off. And it's like, wow. And that's something that he and I actually agree on, right? But it's like, wow, you could
Stand by just a moment, guys. I got somebody at my door. I'll be right back.
Oh, okay.
Sorry.
So he was just simply unable to see that. And I don't know, it's like I said, I don't have a whole lot of hope for it, but we're going to give him that shot. So let's go ahead and put this guy on pause. And again, this is his channel right here. It's called I Can Science That. Very small channel, 377 subscribers. He did not get a lot of comments from the Globers. And I think the Globers were thinking, oh crap, what has he done? He has opened this doorway and we are absolutely going to destroy him on it. And we are absolutely going to destroy him on it. Because, what he has stated here, there is no coming back from. It's as simple as that. So we're going to go through this point by point and, see what he has to say. And I definitely want Baldini to be back. So hopefully he'll get back here in a minute or two. So Baldini, when you get back, just let us know. And then we'll go ahead and start this and guys, we're doing this. Everybody, the only person, as far as I know, that has seen this video on the Globebusters team today is me. Am I wrong in that, guys? Have any of you seen this?
I have not seen it.
Okay. And nope. Okay. Austin?
Nope. I have not seen it.
All right. So this is going to be kind of a reaction video for you guys. And I like I said, when I didn't know whether to laugh or just be in utter disbelief at his attempts to try and cover this, because one of the things he'll start out saying is he'll say, well, you know what, don't say that we're pitching the nose down or the nose has to pitch down. That's a bad term. It's like, really? And then he goes on to use that term constantly over and over and over again. You want to know why? Because it's accurate. It is pitching the nose down. And, this whole straw man argument that he made up about that in the first place is utterly laughable. And like I said, he tells us not to use it, and then he proceeds to use it himself, which again was like, you're kidding, right? So I don't know. I just don't know what to think about. So Baldini, are you back yet? Not back yet. Okay. Well, I do want to wait for a minute for him to be involved in this. So, Erie, you said you had something that you wanted to talk about maybe a little bit later on today if we get to that. What, just out of curiosity, what was that going to be about?
Give me 1 second because I just put something to eat. Give me 1 second and I need to, throw inside my body.
Okay. Well, I'm batting 1,000 here today, I'll tell you.
Sorry, what I missed.
This amazing animation reminds me that I just ordered and received a lab coat. So I'm going to wear a lab coat with glasses and a bow tie, and maybe people will think that I have to know what I'm talking about. Yep.
Okay,
Before
cool.
I was asked, what are your qualifications? Where's your diploma? Let the lab coat fix all that.
Yep.
Sorry, guys. I was preparing for the show and I start eating some seeds that are very dry. I don't know how you name the action to get inside through your throat, but that is what happened to me. What I have to show is it's not really something super detailed, but it's about the Richard Branson new mission to space, if you want to call it like that, because he only reached supposedly 86 kilometers up in the atmosphere. But there is no something like I said, super detailed. We can speak like 15 minutes, 20 minutes, no more than that.
Okay. Yeah, that sounds good. I'm sure we'll have some time to that probably in the second half of the show, but obviously I want to make sure that we get all of this in the first half of the show, because I'm sure that the ballers are not subscribing to us on Rockfin. So I do want to get this out there, at least on this part of the show. So at least we start this dialogue rolling and everybody can have access to it.
I am a little jealous of that quality of 3D, man. I need to, to say it.
Okay.
Yeah. It's amazing.
Awesome. Okay. So Baldini, are you back with us, sir?
I am back.
All right. Let's go ahead and start this show, and I will stop and make commentary. And if you guys have anything to comment, just start talking and I will hit the pause button if you want to express any thoughts on it. And other than that, let's go. Here we go.
Welcome to I Can Science That. Many of you are already aware that I hold degrees in Aeronautical and Aerospace Engineering. With that in mind,
something weird with the audio? It's really broken up. Yeah.
Super cracky.
Oh, okay.
Yeah, super cracky.
Super cracky. Let me restart my virtual audio cable. And I'll try that. Revert and setup. All right. Let's try this. See if this helps any better.
Kicking off a new series today.
Yep.
I call Aerospace Crash Course. This will be a series of videos designed to just skim the surface of some aeronautical topics that are relevant in the alternative science, and particularly the flat Earth discussion. Let's look today. The first one, let's talk about dipping the nose. Now, this is a common complaint we get from people who are skeptical of the globe shape of the Earth. They have heard that as an aircraft flies over a globe-shaped Earth, the aircraft would have to dip its nose as it follows the curve of the Earth. And yet, pilots consistently tell us they do not dip their nose. This is nonsense, they say.
Yes, and that is absolutely true. Pilots do consistently tell us that, except for one, and that's Wolfie 6020, but we'll deal with that at another time. Let's continue.
So how do we resolve that? How can both of those things be true? If you've watched my channel before, you won't be too surprised to find that I'm going to talk a little bit about how we can phrase things differently and how we can try better to understand the questions that are being asked and how to address them more directly, so that the other person does not walk away convinced that we are being deceptive and trying to lie and cover something up. So for you flat earthers out there, I invite you very much to watch this and try your best to understand and engage back and ask follow-up questions about this. I think it's pretty straightforward and understandable if you're willing to do that with me. And for you Globers, maybe there's some useful information in here that you don't already know, or possibly just a different way of looking at it, a way of phrasing things more carefully so that we don't create that sense that we're being deceptive. Let's get into it.
If I could,
go ahead.
So our friend isn't scoring any points with me here with the, real condescending. Yeah, this is really going to be easy to understand if you just listen. Like if you just went to that day at school, it's real easy, guys. And we're just going to rephrase things so you don't think we're being deceptive. We understand what the problem is. We understand that you're convinced you already understand the outcome. And so when you approach the nature of the problem, you're not trying to solve the problem. You're trying to prove. You're trying to create a proof.
Yes, exactly.
That's the fundamental nature. That's why it's dishonest. It's not that you're dishonest. It's that you're intellectually dishonest because you began with a presupposed outcome. And that's the nature of science. That's why you can't science. I'm sorry.
Exactly.
That's not the nature of science. You don't start it with a presupposed outcome. And you can have a theorem, right? And you can test it, but you go where the data leads, right? And starting with, we're going to tell you, it's real simple, dude. You're not helping.
Well, especially when this what it says at the top here, flying over the curve. They say, well, you can't use this terminology. He tells us what terminology we can and cannot use, and then he proceeds to use that exact terminology, which just blew me away. So
I love it. I love hypocrisy.
Yeah.
One of my favorite.
Let's continue on, and we'll show you some great examples of this hypocrisy. Let's go.
The description of the situation is this. There's an aircraft flying over a curved globe, and if the aircraft were to fly in a straight line, I think we'll see that it will end up at a higher altitude than it started. The usual complaint is the plane would fly off into space. Obviously, we all understand the plane will not fly off into space. Planes cannot fly into space. For you flat earthers who may be watching, I will ask you not to phrase the question in this way. The concept of the plane...
I would ask you to use your brain. I mean, clearly it can't fly into space. You know why? Because there's no such thing as space. So let's start that way. Would it fly in a flat, straight vector? Yes. And so if your model says that there's space there, then we have a problem. That problem is not your phraseology, Sparky. I'm sorry.
Exactly.
Yeah,
puts me in a mood.
According to your religion, it would just disintegrate. So whatever.
Yeah. Well, essentially what he's trying to say is that if it's flying above it, and obviously, by the time it gets out here, God knows how high it is, but it's going to be much higher than this little Cessna can go, right? And it simply is not going to have the horsepower or the lift capability to fly off into space. And to that, I agree. Obviously, it can't. And so...
I think he's under the misapprehension that if he talks real slow and puts on a smile, that we'll get it one day. That us window lickers are going to finally go, oh God, I just didn't realize.
I know.
Well, what the hell?
I know. And that is part of the condescending nature of this is like, well, I'm going to talk real slow and I'm going to explain it to you. And you're going to see, how you just are blatantly misunderstanding this. But, stay tuned. The hypocrisy is coming. Here we go.
Plane flying off into space is ridiculous. You know it as well as we do. And it causes the conversation to be derailed. It's a very dismissive way of looking at it. Instead, say it this way. The altitude would increase. The plane started off at a lower altitude, and now it is at a higher altitude. If you flew in a straight line, the plane's elevation above the curved ground would necessarily increase. And to that, we will get no argument. This is...
Let's not say it blew up. Let's say it disambiguated instantaneously.
Well, here's the thing. Yeah. So he is saying here straight up, then, if we flew in a straight line, meaning straight and level, over the Earth, that because of the fact the Earth is supposedly dropping away from us, that by that very nature, even though we are in a straight line, that our altitude would increase. Yes?
There you go.
Okay. No argument with that, but the doublespeak is coming, guys. Here we go.
True. We agree. All globers, all flat earthers, we should agree on this. We're on the same page. Yes, that's absolutely correct. Good job. Good analysis.
Thanks for the pat on the head.
Following a curved surface necessarily means the plane must fly in a curved path. Absolutely.
No. What?
Like
wait, what? Did he just say he flying over a curved surface means that it absolutely must fly in a curved path? Is that what he just said?
That's what he said.
What kind of... I want what he's smoking. What kind of assumption is that? It necessarily must?
That, of course, is nonsense. And,
it's absolute nonsense.
I'll spill the beans on that right now. What obviously this guy isn't, he says he's an aerospace engineer and an aeronautical engineer, but I have to wonder if he's spent 5 minutes, you know, in the
I don't want to be
cockpit
on a
of an
plane he
airplane.
designed, that's for sure.
Yeah, well, or even understands it, because he doesn't seem to understand that, you know, there are also features on the ground, right? We have like in Colorado, you can start in eastern Colorado and be well below 4,000 feet and fly to western Colorado and get, you know, well over 14,000 feet, right? Now, the ground is coming up towards you. And what he's about to insinuate is that the aircraft, by its very nature, is designed to keep that stability and keep that altitude over that.
If that
Earth.
was true, there'd never be such a thing as controlled flight into terrain. Why don't you go check the NTSB safety records on that one, Sparkplug?
Exactly.
That's what controlled flight into terrain is.
Yeah, it's crazy.
Yeah, he's an aerospace engineer, my hand. Okay.
Let's go.
This is what the flat earthers are describing when they say dipping the nose. And yes, I think we can agree that although we do not like the phrase dipping the nose,
he showed it going flat and just losing altitude. So
yeah,
he again misdescribed.
Right. Yeah. So this is dipping the nose, huh?
It's not something that we would say or how we would describe this. This diagram of what I just showed is what the plane will do. It must follow the curve.
No, insane.
This is not what the plane will do. The plane does not fly out here and keep this attitude, because by the time you get over here, you are literally in a high rate of climb, because look at how you would be perpendicular, you know, to the point that it's above. So let's back up just a little bit. Now see down here.
Too many video games, right? That something has a like follow terrain feature.
Yeah.
Is that how he thinks the world works?
Yeah, this is so freaking absurd that he even says this and shows it this way, right? Because this is not how it works, but he's trying to get you to think that this is how it works. But the problem is that with respect to this point, you are tangent to a rather substantial angle to the ground, right?
Well, there's not even an argument here. It's just a statement. He's just saying the plane has to do it. There's no argument.
Yeah.
The plane must do that. No, that's not true. So back up, start over.
No, the plane must not do it, and the plane doesn't do that.
Exactly.
That's the complete fantasy. Let's continue.
Curve. Therefore, yes, the plane must dip its nose as it follows the curve.
As he shows it not dipping its nose as it flies. And didn't he just tell us?
Do it, and then he said, "What?"
Yeah, and he just told us not to use that term.
Poor sweet summer child.
I mean, oh my God. And it gets better, guys. It gets way better. Let's continue.
It's just that we would not normally describe that using the phrase dipping the nose. We would say following the curve or maintaining altitude, but it's odd for us to describe that as dipping the nose. If we instead we understand that.
I'm sorry.
It's odd for us, like who's us for one? Like, okay, so you didn't define us, the ballers, or us? Is he trying to say pilots or us educated people? That's his implication. And so it's difficult for us to understand.
Yeah, I know. I get that. And, you know, well, let's try and give him a little.
It's troublesome.
I know. Let's give him a little bit of latitude, because, of course, you know, this whole dip its nose thing comes right back into play, and he uses it over and over and over again. But so let's give him the benefit of the doubt. I know it's hard, but let's just keep listening to what he has to say, because it does get better.
Okay. That is what they mean when they say the aircraft must dip the nose. I think we can better communicate and understand and respond in a better way. And to any flat earthers out there, please understand, the problem with this is not that we say that this does not happen. We say that it does. It's just that we would not call this dipping the nose. Dipping the nose is not how we would describe that.
I wouldn't call it dipping the nose either, because it's not.
Because
clearly it has not dipped its nose.
It doesn't actually occur. So yeah, we wouldn't call it that either.
Yeah, nor is it occurring in his little diagram here. Right?
Yeah.
So let's continue.
If instead you said follow the curve or maintain altitude, then sure, I think we would all agree that yes, that does happen.
Yeah,
This
I can be
complaint
super
usually-
condescending too. Yeah, I can do that. Yeah,
Okay.
because yeah.
All right. Easy
I
Baldini.
mean-
Easy
All
Baldini.
Okay.
Let him. Let's let him make his case.
comes with the dismissive phrase that the plane would fly off into space. We all understand that planes cannot fly off into space. Let me ask you, why not? Why?
Didn't Richard Branson just fly off into space in his plane?
Well, again, that seems to be the entirety of his argument is just semantics. He doesn't like the term fly off into space because it's ridiculous. Well, of course it's patently ridiculous. That's why we say that. Your argument's ridiculous. And then he doesn't like dipping the nose as a statement. We wouldn't call it that. Well, we don't call it that either because it doesn't occur. So his entire argument's is impossible straw man. Nobody says that.
Yeah.
It's the fault is with their argument. We're pointing out as the absurdity of their argument. And he says, well, that's absurd. Well, of course it's absurd. That's why your argument doesn't work.
That's right. So, Iru, here you go. This is from an aerospace engineer for your presentation on Richard Branson. Here's his quote: "Planes can't fly into space." All right. There it is. Aerospace aeronautical engineer has just debunked
maybe
Branson.
Yeah, no, not just this guy. I read a lot of headlines from digital articles that, of course, a lot of people claim that 80 kilometers is not going into space. Of course, even the great Tyson, he said, sorry, but Richard Branson didn't get into space. But of course, with typical propeller like this, I don't know how you name the front motor with the hélices. Help me to describe that part. But
the front motor, the fuselage, is that what you're talking about?
Yeah,
or?
the front motor has these blades. It's called
The propeller, right?
The propeller with blades. Of course, that is this. In this case, this little plane is not going to reach anything. In the case of Richard Branson, they use a solid rocket motor attached just to a simply pyramid plane, because if you take a look, it's like a pyramid, that plane, and they call Unity 22, and there is things that are very symbolic. But my question is, what type of device an engineering can invent and build to draw along a certain path the curvature of the Earth? Because the rest of the equipment, everything is like work in a flat plane. They assume that there is in the flat plane, and you need to imagine that, well, the gyroscope is self-oriented, blah, blah, blah. But can anyone or someone build something to describe the curvature of the Earth? It's drawing in real time as the object moves in the air, in the ground, whatever.
No, there is no math for it. And in fact, the math that he introduces here is clearly designed, even by his own admission, for flight in a non-rotating, flat, straight and level Earth, right?
Yeah, well, that's the problem. That's the problem. I mean, there is no any device, mechanical device, to describe or better say to draw the curvature of the Earth without any doubt about it.
Absolutely.
There is no equipment. There is nothing to do that. Everything is described a flat plane.
All the documents from NASA forward for all of flight describes a flat non-rotating surface. And the other thing is just about guarantee I'll put $5 down that whatever formula he gives for deriving that it's going to go over the curve is only a two-dimensional. It does not take into account. It's a three-dimensional axis. And they never do, right? Because they're always trying to get you to visualize an orthographic view going side to side. They never take into account the z-axis. And it just blows their argument apart. So again, you'd have to figure all these things in real time in three axis, and it's not possible, and it doesn't happen. Right, it's a flat, non-rotating plane. At least that's what it appears to be, and that's the way we treat it, and that's the way everything functions. So,
and yes, Hiro,
that's the only claim I can make. That's the way we treat it. That's the way it functions.
That's right. And yes, Hiro, we do have a piece of equipment that, if the Earth was curved, it would absolutely detect it. That piece of equipment is the gyroscope, because the rule is if you're flying along, you must necessarily change the pitch of the aircraft. If you fly all the way around the world, then you have to do it at the, 1 full 360 degree turn. The problem is that has never, ever been measured, ever. And the ballers will try and come up with all kinds of excuses, namely that, oh, they're just not sensitive enough to do that, which of course we've debunked that. Not only are they easily able to detect the curvature as you're flying over it, but even if they're just sitting still and the Earth is rotating at supposedly 15 degrees per hour, the gyroscope would be very capable of picking up that 15 degree per hour drift. It does not. So what is their excuse? Their excuse is well, it's the gimbals are too restrictive and therefore it can't pick it up. I mean, just a whole bunch of excuses, which is nonsense, because what we did on the flat earther side is we took a gyroscope, in fact, it's the exact same precision gyroscope that I have, and we put it on what's called a 7-day recorder. Okay. And what the recorder is, they use these things for like earthquakes and stuff like that. It's a big, huge wheel that turns 1 RPM or 1 revolution in 7 days, meaning it turns 1.2 degrees per hour. What did we find? We found that the gyroscope not only registered that 1.2 degrees per hour, but it did it extremely accurately. So to then say that, well, it's too restrictive on the gimbals to pick up that 15 degrees per hour rotation, on a normal gyroscope is utterly preposterous. And that's also exactly what that US Navy video was saying at the beginning, is that you must necessarily, after you've been flying a quarter of the way around the Earth, you've got to be pointing straight down. Nose has to be straight down, and the gyroscope must reflect that, but it doesn't. So what do you do? All right, let's continue.
Why is it that planes cannot fly off into space? And I think our skeptic friends, they know the answer to. They're shouting it at me right now. I hear you back there.
Space is fake.
You understand it. You understand it. The reason planes cannot fly into space
because it's fake
is because as you climb higher in altitude, the air becomes thinner. When the air is too thin, the wings can't generate any more lift. They can't generate enough lift to go any higher, and the plane simply cannot go any higher. So we understand that. You all understand that.
Yeah, we understand that very
We're not
clearly.
saying that. Yeah, we understand that. We're saying that the problem is yours, not ours.
And also, as how you go, you don't have nothing to push against. So we have travels with thrusters, and we have travel with blades and airlifting. So we have travels in any model.
Yes, rockets, missiles.
Rockets, yeah, whatever. Yeah, exactly. So those problems are in your model, not the one we don't sell. We just see what's going on, and we say, hey, look, this is what's happening. So anyway.
Exactly. And that's and the fact that rockets cannot possibly propel anything in a vacuum is an argument that is so easily proven and so easily disproven, when you come up with your examples, that it's just ridiculous. It really is. It can't be done. And anytime that anybody's ever tried to do this, they have straight up cheated on it. They will sit there and put it in a small box. They'll light the rocket motor. The rocket motor will fill the box with all kinds of gaseous material, which then at some point will provide enough of a medium to then push off of. But when you're doing it inside of a 10 to the negative 17th vacuum of space, 10 to the negative 17th torr vacuum of space, it's never going to accumulate, ever. So anyway, but we're getting off track on this. Let's continue.
So let's take a look at what this means in terms of following the curve and dipping the nose. At this point, I traditionally warn people I'm going to be showing a little bit of math, but I would encourage you to stick with it. This is not difficult. It's very simple math. It looks kind of ugly, but really we're going to use it in a very, very simple way.
No, actually it is very, very simple. Unfortunately, dude, it doesn't explain anything, especially not anything relevant to what we're covering here, but I'll cover that after you show the math.
Let's take a look at the lift equation. I think we all understand that the aircraft has some weight And if we want to fly along at a nice steady level rate where we're not falling and we're not climbing, we'll need lift to be generated in exactly the amount to balance the weight. If they're perfectly balanced, then the aircraft will stay at a steady place and will not be accelerating upwards or downwards. Here is the lift equation. This is the math that I promised. This is what has been discovered over decades of research, just experimenting in wind tunnels and with aircraft. This has been discovered to be how the natural behavior of flight works. Let's describe the terms here. This is the lift that I was talking about right here. This first term is the lift coefficient, or coefficient of lift. And we'll get into that a little bit more later, but for now, let's just consider that to be a constant that describes how lifty the aircraft is in its current configuration at its current flying status.
How lifty.
You sounded like me last night, Baldini. I was dying.
God, that's awesome.
Except it was on the second video that I was dying.
Well, okay, it's great. So here's some math. It's not too difficult. Okay, so here's this. Well, I'll get into that later. It just describes how lifty the plane. Oh man, this is epic. I love it. All right. Continue.
Yes. Okay. Continue.
I'm sorry.
This term here, this Greek letter looks like a P, is rho. That rho represents the density of the air that you're flying through. This V here is the airspeed of the aircraft. The aircraft, of course, flies through the air, and it is the air moving past the aircraft that generates these forces. So it is the airspeed that's important here, and you'll see that that is squared. And then that velocity quantity divided by 2.
Who's counting? Right.
Exactly. It's rho velocity, rho times velocity squared, is supposedly what gives us this standardized lift. But what this doesn't, and I'm not even going to go into this, but yeah, I am going to go into this. You know what? What this doesn't cover is a myriad of other things. Yes, the rho value would necessarily take in the density altitude. Times the velocity squared, but you also have to look at how the wing is actually operating. And let me tell you something about how wings are said to operate. When you go to pilot school, they say that the wings basically are operating by when you have a cambered wing, right? So you have a cambered wing, meaning that it has a longer distance. The air has a longer distance to travel over the top than it does the bottom, okay? And so what happens is the wind is coming in, it hits the leading edge of the wind, the wing, and it splits, right? So then this air is necessarily accelerated to go faster because it has a longer distance to go to be able to meet up with the air at the back of the wing, right? What this does theoretically is it causes a low pressure area above the wing, and this is called the Bernoulli principle. Okay. Now, there's a problem with the Bernoulli principle, and we're not even going to go into that. But I as a side note, I'd love for you to cover this, Mr. Aerospace Engineer. If this is true and this is the way that this actually works, then how do you explain a symmetrical wing design? What is a symmetrical wing design? Well, there are lots of aircraft out there, especially that are meant for like aerobatics or high performance, that the wing has the same amount of curvature over the top that it does over the bottom. Therefore, there is no wind speed differential going over the top versus going over the bottom, right? So then Bernoulli principle seems to go away in that, right? But again, this is not taken into this equation. There's a lot of things that are not taken into this equation, but that is something that I would love to have answered
Your point is well made in terms of that, but my point is simply that it's absolutely irrelevant to the argument he's trying to make. He's saying that red and blue make purple, and that's why the steak is delicious. It has no bearing on it whatsoever. Aerodynamics, right, function of fluid dynamics, a derivative. Lift is a function of that, so that has nothing at all to do with the tilted, right, the downward vector of the airplane. As it has nothing to do with geometry, right, and the flight characteristics in terms of the direction of the plane, whether it has to tilt downwards, right?
Right. And the other thing he's going to basically describe out here is that this only seems to take effect when you're dealing with the curvature of the Earth. What about land features at the bottom of the Earth? What if you have like mountains that are coming up, right?
That's what I said about controlled flight into the terrain. It would do the same thing with a mountain, right? The arguments.
It's ridiculous.
And the thing is, again, I don't think, and here's the thing is his main concern seems to be that people think he's being disingenuous. I don't think he's being disingenuous other than to himself. I think he's trying very hard to convince himself of why what he believes is true. And I appreciate that. I appreciate the mental gymnastics, but this is inside you, my friend. This is not out here, right? Out here, the world looks and behaves this way, and we can demonstrate that. What's going on in your head is something very different, right? So you've approached us with, look how smart I am. I know these math and that sort of stuff, so it means I'm smart enough to understand this. But your argument demonstrates that you've missed the logic altogether. So come back to that part, right? Look at that part and really look at why you're afraid of it and why it's so important to you. Because really, if you don't believe it, this shouldn't be important to you at all. You should go back to your textbooks and learn how to build an airplane, right? It shouldn't matter at all. Except for that your textbook will tell you that you're working with a flat, non-rotating surface. That's the problem.
Yes, and he even admits that, by the way. But you know what he says? He goes, now, you may even find that the textbooks will tell you that it's a flat, non-rotating surface, but it only says that because we know that it's not. And it's like, whoa, talk about a hand wave dismissal.
And that's cognitive dissonance.
That is cognitive dissonance, yes. You're going to hear that, coming up real shortly. Let's continue.
And then finally, multiplied by S. It's a reference area, so I put S sub ref. It's an area, and it's really not important what that's the area of. So we'll skip past that.
So
this is our...
Yeah, it doesn't matter.
It doesn't matter. It actually does. That's the amount of surface area because that represents how much lift you can get relative to the weight and density and mass of the aircraft in terms of its relative to its speed. And, of course, the air density. Oh, Jesus. This boy's lost.
Yes, he is. Let's continue.
Our equation that, through experimentation, we have determined describes how lift seems to work. Let's see what happens as you climb higher in the air. As you go higher in the air, we all know the air gets thinner, and that means less dense. So the density term right here is reducing as you climb higher in altitude. And simply by looking at this equation, we can see that if you reduce this side, that means you must reduce the other side. If rho gets smaller, lift gets smaller also. So looking over here, the lift is now too small to balance the weight of the aircraft, which causes what? If the lift gets smaller, but the weight stays the same, what do you say over there in the back? Yes, that's right. It starts to sink. Specifically, it will accelerate downward. That's exactly right. So what happens when the aircraft sinks? Of course, as you sink, the density will increase again, and the lift will come back up until you're back where you started and everything's back in balance.
So what he's saying
I get it now. I get it now. He's saying it goes out there. It really does go out there, but then the air density is thinner. And so because the air density, the air mass is less, it just sinks. It just drops down. And it doesn't have, the pitch doesn't have to change at all. It just falls.
It just sinks, exactly. So what he's saying is that if he flies out, if I jump in an airplane and I fly out over the Grand Canyon, right? Mm-hmm. And the Grand Canyon falls away at, a dramatic, because of the fact that the terrain below me has sunk, that means that
You're going
airplane
down
is
like a
automatic. No, it says it would say that it's automatically going to climb, right? By what he's saying.
Well, he's saying that if your air pressure gets less, he's basically saying if your air pressure is less, then you're going to drop.
Yeah,
feature wouldn't matter, right? The air pressure gets less, you're going to drop.
Exactly.
But the way he's describing it is that what occurs is that you fly out into space. He doesn't like that. You increase in altitude. Okay, we'll play that game. But as you go away, as you fly out there, the Earth's curvature falls away from underneath you, and now you have less mass, and so it just gently falls.
Yep. Oh, and you know what? You're right.
That's what he's trying to describe.
You're right.
That's what he's trying to describe as your. Yeah.
So it means that if I fly out over the Grand Canyon because of the fact that it's dropped away from me, right? Then automatically I am going to sink. You're right. You're
going to sink like a rock.
Yes.
Yeah, exactly.
Going to sink like a rock. That doesn't happen. I'm sorry. It doesn't happen, especially. And remember, what about when you're flying over a sheer cliff, right? Like it would be something in the Grand Canyon, right? You're going to tell me that all of a sudden that air pressure differential is going to be changed radically, instantaneously at flight level? No, it's not. It absolutely is not.
Well, and I can just hear, Wolfie and others going, "Oh no, it's the pressure gradient that goes on." Yeah, so it's a smooth pressure gradient. So it just gently drops. Again, it doesn't do that. And again, what would occur is still, again, flight characteristics would still mean it wouldn't still drop your nose. The altitude of the nose would still have to drop to follow exactly the terrain that you would never notice. And the flight characteristics would change. You'd eventually go into a stall.
Right, but he's saying
definitely notice that shit.
He's saying that the nose never drops, right? It's just basically what's happening is because it's dropping out from underneath, then all of a sudden rho v is changing, and therefore L is changing, and it's going to sink, right?
Okay, so here's even if I give that to him, right? Even if we were to give that to him, which is nonsense, then the problem is that you would have to set the flight level at exactly the right thing, and it would be flying right exactly at that equilibrium point, right? All the time, no matter what you set your flight level at, it would follow that curvature perfectly, no matter what. And that's nonsense. Otherwise, the aircraft wouldn't be able to climb, right? So if it did that, right? If it did that and said, "Oh, you can't fly any further because it's just going to sink," well, how would you then gain altitude? Spark plug, right? You have to be able to maneuver and navigate the aircraft. So you're saying when you climb in altitude, the air pressure gets less, and so you're going to drop. Well, how then do you climb to 30,000 feet? Your argument doesn't work, right? So you've latched onto an idea and you're trying to run with it, but you're out in the weeds. So just come back and just look at the way the world works, right? Stop trying to make the argument and just look at what happens.
He might be in the chat, Bob.
He might be in the chat?
That'd be awesome.
Oh, he is in there.
Yeah, I think it is him.
Outstanding.
Good. Okay, yeah, he is in there. Excellent. Good. I can science that. Oh, gold speakers don't seem to notice me, and the crowd have questions.
Well,
okay.
He was saying earlier that he can, if you want to ask me anything, I'm here. And then I didn't know if it was him at that point, but then, yeah, he's saying that we're not recognizing him. So if we had questions, he would come on.
It's not intentional. I promise.
No, a lot of us don't have, it gets distracting when we look at both. But he's there if you wanted to bring him on.
Yep. No, actually, I do not. I want this to be answered, via video because, I've spoken to him about items like this. And like I said, the cognitive dissonance goes completely, off the charts, right? It's frankly unbelievable. And, I'm not going to disclose that because we're going to get way off in the weeds on that. But I want to address the points as he's made it. And then he is fully welcome to add his rebuttals. But in doing so, we also want questions answered like, why isn't this ever reflected in the gyroscopes? Because it's not. And all these other things, any other of the flight instruments, even radar altimeters, right? You could say, well, you have two types of altimeters. You have pressure altimeters, which work off barometric pressure, and you have radar altimeters, and planes use both types, right? So which one is really going to be tied into the navigation system that's going to be driving you up and down, with the terrain and the changing lay of the land, so to speak, right? Doesn't work. So let's continue on.
So as you climb, the air gets thinner, and that makes the plane sink down. How far does it sink? It will sink until the air gets dense enough that the lift and the weight are balanced again. If the aircraft dives down, if it sinks down too low, the density will be higher, lift will be increased, and it'll pop back up. Like a little balloon, it will maintain a level where the density is causing that lift.
No, planes don't work like, it's not like scuba. You're not working on neutral buoyancy. It's working on lift and vector, right? Velocity. It's a different principle. He's trying to make it scuba and neutral buoyancy, but it's always, again, that's what I described before. It's always right on that level, right? It's always on the balance between. That's not how it works.
No, it's not. Okay, and he's sitting there, saying, "You guys all hear this, right? They don't want me to come on." No. We want you to answer this on your own video, your own time, because I don't think you'd like it any better if we were sitting there, distracting you every 2 seconds with what you would consider non sequitur nonsense. And, everything that you have put forward so far, dude, has been ridiculous.
I'll say this. I'll address him directly. I don't have any personal animosity towards you, like I don't for most people. Although I would say that you kind of came off a little condescending, and a lot of your materials, your arguments were weak at best. However, again, the fact that you're focused on this says way more about you, right, than it does about us, and as well as the misapprehension that people who don't see the world as a ball spinning through space are not retarded, nor did we miss that day of school. It is because we found holes in the argument, and we were able to really take a look at it very seriously without hanging on to it. So again, I would just say, rather than trying to convince us, because we've already done the research, right? Maybe you should, I don't know, look at that aspect about yourself that makes that so important to you. That's all.
Yes, I agree. Okay, let's continue.
To exactly balance the weight. What this equation tells us is that the plane naturally will follow along a line of constant air density. That's what it does naturally. This equation is not something we have imposed or programmed into the aircraft. This is something we have discovered by observing how they work. This is just how wings work. So that means if the Earth is flat, a line of constant air density is a straight line. But if the Earth is a globe, a line of constant air density is a curve. And the lift equation says that the airplane must naturally, all by itself, follow along with whatever that is. So
yeah, the only problem with that is that, again, you're completely ignoring the ground features. You're saying, okay, well, yeah, according to the curvature of the Earth, it's going to follow that because it's the curvature of the Earth. But that's not the only z-axis that's out there, dude. The other z-axis out there is clearly the terrain below you, right? Which, if we follow these equations the way that you are putting them forward, then that would tell me that that airplane would have to be jumping around all over the place. Now, you did say that the equation tells us that the plane will naturally follow a line of constant air density, which I agree with. But then you try and dismiss that by saying that, when the curvature of the Earth changes, that's automatically going to instantaneously change the air density for the aircraft, and it's going to follow the curve. But what you have not done is what about when the terrain naturally undulates itself, like if you fly out over the top of the Grand Canyon or something like that. See, you're only looking at it on your one side, and you're failing miserably in explaining the other side of the equation. So, just make notes of this, dude. And I'm looking forward to hear your response. Let's continue.
And I'll say with, again, absolute clarity, my claim is that, again, I'm not an aerospace engineer. I'm not a pilot, although my father was a pilot. I grew up around it. But I do work in the field of applied physics. I have for a very long time. And I understand the basic laws of physics well enough to follow along such that I can observe them and, again, see what happens and what does not. That's all.
Yep. Agreed. Continue.
This equation tells us that planes naturally, all by themselves, will dip their nose as they cruise along.
True.
Yet another reason why we don't like to call that dipping the nose, because I'm not doing anything. The plane just does that. That's just what it does.
So you're saying that this equation tells us that the plane naturally will dip its nose as it's flying along, but we don't like to call it that.
Yeah.
And yet that's what it's doing. And frankly, if we were on a ball Earth, yes, it absolutely would be dipping its nose, as you are going to reiterate over and over and over again in this very video. Let's continue.
Well, what I think he's trying to describe is that, it wouldn't have to dip its nose. It would simply lose altitude, like as though it were dropping buoyancy. And again, that's not the way the nature of aerodynamics work. If it were a balloon, perhaps it would look sort of similar to that. But again, you're not, again, accounting for the angle, the incident angle of the aircraft. Because again, if the curvature was going away, the incident angle of the aircraft would have to follow that as well. And that would, it would absolutely have to affect the flight vector, right? So, I don't know, man.
And he says, thanks for the publicity, but I'm not planning on getting into a back and forth video session with you. Why not? What's wrong with it? Are you scared? Are you chicken?
Didn't you start? I mean, isn't that what your purpose was to begin with?
Yeah, you asked for this.
Is to choose a large channel and then take them on so that you'll get the attention. I mean, isn't that what you did essentially to start with? And then we tell you the problems with it and you say you're not looking for it? That seems odd.
Yeah, you're seriously looking for it, and you're going to continue this, and there's no way that you're not going to address these things. And if you don't address these things, we're going to call it out point blank. So not only had you better address it, but you better address it in a way that is coherent and makes sense, and not this double speak, which is exactly what you're talking about here. This whole presentation has been nothing but double speak, and it is ridiculous, every bit of it. So let's continue.
It goes that way, and if it gets too high, it comes back down. If it gets too low, it goes back up. So it just maintains that same density. And so if that density range curves, well, then the plane's going to curve to follow along with it. Planes naturally follow along the line of constant air density. And if it's curved, that means the curved flight path is the natural behavior of any flying object, be it an airplane or a bird, anything. The pilot does not need to do anything specific to make that happen. It's just what planes do. So, there's been some talk.
And let's not forget, Wolfie6020 vehemently disagrees with you. Go look at his very first video, or maybe first, second, or third one. I don't remember which one it was, but we covered it a long time ago when he's saying, oh, yeah, you got to do that for sure. But, you do it in very, very small increments, and you don't even know you're doing it. It's like, give me a break. You know you're doing it because you have instrumentation that would tell you if you were not correcting for something that was causing disequilibrium in the flight mode. I'm sorry, but that's absurd. They don't just do that. Yes, they are designed to be stable in airflow. And in fact, one of the things that a flight instructor will tell you is that if you get in trouble and you get when you get disoriented, okay? One of the best things you can do is just simply let go of the flight controls, and the plane will naturally try and reorient itself to a straight and level flight. That's absolutely true. So when you say that, that's true, but you're trying to make it sound like the plane is automatically responding to this curvature of the Earth, by making note of the density at flight level, and yet you are not explaining why the surface features of the air would not cause the plane to do the same thing. Because I'll tell you why, because it's nonsense. That's why. Let's continue.
Well, I guess I got one additional question, and maybe I have a piece of advice to follow Bob's previously. But the question is, it just asked this question: if, for example, if you just entertained for even a moment, right, the possibility that it is a flat and level surface, just like the documents tell us, and just like your ground school tells you, to treat it, right? If it were in fact if that were the case, what would be different than what we see now?
Yeah, exactly.
Just think it through. Just think it through. That's all I'm saying. And then what additional explanation would it require? And then refer to Occam's razor. All right, continue.
Good call. Here we go.
Recently of autopilots, and would autopilots need to be programmed for this? And no, they do not need to be programmed to follow the curve, because planes naturally follow the curve. What pilots and autopilots are doing is they are maintaining altitude, right? They have a gauge in their cockpit that's called the altimeter, and it shows them how high up they are. And they just maintain that at the specified height. So a pilot will just glance down at the altimeter once in a while and make sure he's in the right spot, and if not, make a few corrections. And what an autopilot does is it will have an altitude hold function, where it's just simply told to, like a cruise control in your car, maintain this by yourself. And what it maintains is altitude. That's your basic autopilot, is an altitude hold. So you'll just set it. You'll say, hey, the current altitude that I'm at, I want you to hold that altitude. You set your cruise control, and then the plane will notice if the altitude has gone a little too high or a little too low. It will make adjustments based on that, and it doesn't care what the shape of the Earth is. It has nothing to do with it whatsoever.
Okay, it doesn't care what the shape of the Earth is, but yet you're saying that, somehow it may not care, but it seems to know automatically that the Earth is curving away, right? And so that would indicate then that you're saying that the pressure differential is what the autopilot is setting, its autopilot flight on, right? Which would be AGL, or above ground level, right? And it doesn't do that over terrain changes, but it does do it for the z-axis curvature of the Earth. Again, that is a non sequitur argument. It makes absolutely no sense. So let's continue.
And also, I make a little note here. It's worth thinking about the fact that this altimeter, this altitude gauge that the pilot is looking at, that's based on density. That's measuring the density of the air. Specifically, it's measuring the pressure of the air, which can be used as a proxy for density. And it's measuring that, and that's how it knows how high to be. So what pilots are doing is following a line of constant air density, just like the plane naturally wants to do all by itself. So that's why pilots do not have to do anything about this. It is completely normal. And autopilots don't have any specific subroutine that's got the radius of the Earth like in there for following the curve, because the autopilot is just programmed to hold that altitude. So let's summarize now. Right. What did we learn from this video?
Nothing.
The first thing I think we learned is,
well, I can tell you what I learned. I mean,
don't say.
Oops, go ahead.
I'll tell you what I learned, right, is that this is a great example of what happens when you have a strongly held belief and you meet somebody introduces you to information that challenges that belief. And you don't believe you can be wrong. And again, this is just it's easier to fool someone to tell them, convince them that they have been fooled. And so immediately they say, I'm smart, I'm going to prove it. And I'm going to give you all these ad hoc explanations why it cannot be, without really thinking through the argument, because they just know it can't be. And so they instantly make some presumptions that the people who making that argument can't know what they're talking about. They just don't know, that they want things to be a certain way, that they're big conspiracy theorists and that's what they like. They just want it to be like that. There's all sorts of reasons that they'll convince themselves of. And you can see it happen. They start to flounder. They start off with a great deal of confidence and bluster. And then they begin using terms. And again, from a body language, if you were interrogating somebody, you'd say like they're hiding time. This is where they're hiding details. details. That doesn't matter. We'll get to that later. He starts throwing a lot of that stuff in there, and that's not germane to the equation, right? And on the biggest part of the equation, right, the surface, is the division. Like that's how you have to know how much surface area creates the lift. So ignoring that, I mean, clearly demonstrates something. So this is just it's kind of sad actually to see it flounder. Like this is why kind of generally I don't enjoy these kind of things typically because the back and forth. I like a spirited back and forth conversation, but in this it seems like again there's no real search for information. It's to defend a point really of I can't have been fooled. And my advice, Bob says absolutely do a response, and I would say find another hobby, get a girlfriend, right? Get a pet. Get a house plant, for fuck's sake. I don't care. But going around trying to change, like you're going to correct flat earthers because like you're saving the world that way. I don't think that's helpful. And these arguments aren't helping. There you go. That's my take.
Planes.
Oops. Yeah, I agree with that. It's because. Oh, go ahead, Austin, or whoever.
Well, yeah. So the plane is just basically his summary is that the plane is actually magically falling down around the convexity of terra firma. You just don't know it.
Because that's just what planes do, Austin. They just do that.
That's the argument.
They don't have to do anything special. They don't have to program them or fly that way. They just do it. That's the nature of what planes do.
Very dynamic
it's
behavior.
Magic. It's magic.
That's what they do. It's in their DNA, you might say.
Yes, very, very dynamic behavior, which of course is preposterous. The plane only does what it is told to do. The plane only responds to the environment around it. And, these things that you're saying, it's akin to saying, well, it just does this because it just does. Things go down just because they do. No, there's a reason that things go down. There's a reason that planes fly the way they do. There's all kinds of things like this. You cannot just say just because that's not going to cut it. And again, like I said, if all of these things that you said are true, and if any of what you said is true, it's all going to be reflected in the behavior of the gyroscope, right? The flight instrument, the gyroscope, and don't come in there with this ridiculous pendulous vanes argument that's been debunked, or Schuler tuning, because gyroscopes' claim to fame is rigidity in space. They do not register any pitch change whatsoever in any aircraft ever. Not ever. Okay? So, you're going to have to explain that. And you're going to have to do it in such a way that, it's going to have to be spectacular. But we know
if it just did that on its own, trim controls would be pointless. I mean,
exactly.
I don't know what to say.
You can trim for straight and level flight and literally go hundreds of miles and not have to touch it, assuming you don't have a lot of wind shears and downdrafts and whatever. But on a fairly decent, calm day, you can trim out your aircraft and you can literally fly for hundreds of miles. And the airplane is not just automatically compensating for curvature. That is so ridiculous. So let's finish this out.
Planes must dip the nose. Instead, just say planes have to follow the curvature. And then I think we can all agree that yes, absolutely, the planes must follow the curvature.
No, because there is no curvature.
Yeah, there is no curvature, dude. That's the whole thing. There is no damn curvature. It's that you can't measure it. You can't even see it. You tell us in your globe model that, no, there's no geometric horizon. You can't see that. It's always apparent. It's like, no, dude. In order to have a geometrical curve, right, there must be an actual physical tangent point where the Earth meets the sky. You cannot simply say you can't see it, especially if you're only photographing from a foot above the ground when you should be seeing it about 1.2 miles away, that physical curvature. And you're saying that we can't see that at 1.2 miles an hour or 1.2 miles away? You're right. Why? Because it's not there.
And there you go, Bob. I mean, I think we can just, with this slide that he's got up right here, take this summary and just turn it around. Go first demonstrate that curve. And so planes must follow the curve. So first you must demonstrate the curve, and then we can go back to here and talk about this aspect. But first you must demonstrate the curve, and we can't do it. So
his argument's really simple. The plane was designed to assume a flat, non-rotating surface. It maintains a pressure zone assuming such. Every aspect and mechanism of it does this. But if we assume the Earth's in fact a ball, then it magically compensates for it. That's
just what planes do.
It is so asinine. It's unbelievable. And the fact that he cannot see or hear what he is saying is really, wow. I mean, I don't even know how to respond to that.
That part is actually not surprising to me, right? The rest of it that comes out is, to me, it's just, it's when they begin to flounder toward the end, and they'll start to wrap it up. And this is the unfortunate part, right? So you're always going to bump into somebody who knows more about the topic than you do, especially when truth is not on your side. Ouch. It's going to leave a mark.
Yeah, indeed. Let's continue.
Absolutely do. If that's what you mean by dipping the nose, then okay, but just, don't call it that, and then we'll be cool. And if a pilot says, no, I do not have to dip the nose, that would be a natural answer for them, because they don't have to do that. They don't do anything specific to accomplish this, because that's just how planes do. The plane just does it naturally.
That's how they be. Mm-hmm. Most people don't think things can be like they do, but they is. Mm-hmm.
I know. No, it is not just what they do. It does not just happen naturally. That is so ridiculous. Again, let's.
The Wright brothers would have found him fascinating.
Yeah, no doubt.
Prove. We've learned that aircraft will stay at a constant altitude no matter what the shape of the Earth is. So that means
really?
This doesn't prove anything about the shape.
So he's saying that the aircraft will stay at the constant altitude no matter what the shape of the Earth is. And of course, that shape would also include the terrain below it. You know what? What that tells me, dude, is that you may be an aerospace engineer, but you obviously haven't spent 5 minutes in the cockpit of an aircraft, because you start flying over undulous terrain and you come back in and make that statement. That's just ridiculous. Absolutely not true.
We have learned that on the curvature, a curved surface on a globe Earth, that the altitude wouldn't change, because the way we know that is by assuming the Earth's a curve and nothing changes.
Yeah.
Right, like that. That's it.
Cool story, bro.
Of the Earth. It could be flat. It could be curved. This particular topic doesn't help us with that conversation at all. But I do want to emphasize, if you thought that it did, if you thought that this dipping the nose argument was proof that the Earth is flat, possibly you were mistaken. And I think that you don't have to give up your whole flat Earth idea just because of this, because like I just said.
Oh, just because we're wrong, we don't have to give up our whole flat Earth idea? Really? Are you really saying that, dude?
Oh, that's generous.
The ego. Oh my God. The ego of this guy is beyond belief. Wow.
It doesn't prove the Earth is a globe. It doesn't prove anything.
No, it does. It proves that the Earth is not a globe, and it proves it in a myriad of ways. You have done nothing to prove anything, and then you turn right around and admit that, well, what I've just said here today doesn't prove anything. No, you're wrong. It proves that it's not a globe. There is no curvature. It does not just do that all by itself. You are ignoring features of the terrain below it. You are saying automatically that somehow the airplane knows just simply by where it's at up in the atmosphere, and it's going to adjust perfectly at 8 inches per mile squared curvature as it goes over, which, by the way, when you take that from a specific point, depending on how far you want to make that point of reference, right? Then your rate of descent starts going down exponentially. I mean, 1 minute it's 2 foot per minute, then the next minute it's 10 foot per minute, then the next minute it's 300 foot per minute, then the next minute it's 2,700 foot per minute, then the next, and these are averages, right? These are averages. So obviously when you think about the extremes of the averages, there have to be points along that curvature, right? That it is pointing damn near straight down. It doesn't happen. you would not only detect that, your vestibular system would detect that, the rate of climb indicators would detect that, the gyroscopes would certainly detect that, and any type accelerometer would detect that. You know what? None of them detect it. None of them. Okay? That's what you need to explain why that doesn't happen.
What it proves is maybe you should rethink who you're trusting about your evidence, because we just discovered that this one is not evidence one way or the other.
Yeah, in other words, is don't trust Globebusters or any other person that's on the flat earth side. Trust us. Trust me, because I have that piece of paper that I can come up here and speak complete and total double speak, and you guys have to understand what I'm saying. I'm sorry, dude.
I just say play it again, and I'll just say physician, heal thyself.
Yeah, totally.
Yeah, exactly. Textbook self-projection.
Totally. Textbook self-projection. That is absolutely true.
And shouldn't be brought up as if it was. The last time I had this conversation with a globe skeptic, the natural response was, what about the rotation of the plane? All the diagrams that I've shown showed the plane flying along and then going along the curve, but it didn't show the plane curving, dipping, angling along the curve, and maybe that's something we should get into. And I agree. And as I told that person, that's a very good question, something we should look into. And I'm going to say now, yes. Follow along with the next video, and we'll get into whether or not the plane needs to rotate as it follows that curve. Of course, we know that it needs to,
I have to?
Whether it does or not, and whether that's something the pilot must do that I have neglected or breezed over here. Look for that in an upcoming video. Okay, until next time.
I love you, Bob, but why do you do it to me, man?
And like I said, part 2 is the part where it really gets absurd. Why? Because he got absolutely eaten alive in the comments of this. And you guys can go look at this yourself. But he completely obfuscates everything about the curvature, just hand wave dismissing it. Again, and nobody even mentioned anything like what I said. It's like, how come on the very device that is meant to measure pitch change, right? The gyroscope, that we can't ever measure this pitch change flying around the world, nor have we ever measured it, nor has anybody ever demonstrated it. And when we do say that your response to it is, well, it's not sensitive enough to do that. That is so patently absurd. It's just ridiculous.
I thought that's just what planes do.
Yeah, it's just what planes do. Absolutely.
I was confused. I don't know.
Wait, I got to do this. I hate to throw this guy under the bus, but so I hit him up in the chat, right? And I said, if you actually checked into it, you would realize that we falsified the radius value, bud. And he said, I would agree that long distance photos seem to indicate a radius somewhat larger than predicted. Well, I'm sorry. That means the entire model's wrong, bro. Welcome to Flat Earth.
Somewhat larger than predicted.
That's right. If the radius has been falsified, your whole damn model, everything about it is wrong.
By like a full order of magnitude in that one.
No, refraction.
Oh.
No, the Earth is breathing in and out. You didn't know.
Yeah.
Oh, God, you guys get me every time. Every time I think I have a point, man, you guys come and just knock it down. Thanks.
Refraction and its gravity.
Oh.
It's gravity and its refraction.
Oh, gravity refraction.
Hey, they do another video, announcing that you've come to Flat Earth and we'll embrace you, bro. No worries.
Yeah,
we will actually.
It would be nice to have an aerospace engineer, on board. That would be great, but not as long as your cognitive dissonance is at this level, because man, it's bad. It's
just funny. I mean, we've been trying to say this forever, right? It's what happens. The issue here is, and I'm not sure how we can explain to people any clearer, that by teaching all of these yes men, I'll call them that or whatever, that they're smart because they can repeat and memorize these facts, that they just will never see the other side. To them, it's impossible that a textbook would lie to them and what they memorized was false. Therefore, anything coming from outside of that must be wrong. Has to be. There's no other option, because the other option means, wait, what do you mean I was lied to? And we've heard all the quotes. It's obviously way easier to convince somebody, or it's harder to convince somebody they've been lied to than to just actually lie to them. So I don't know when they'll ever, see it, Bob. I was asking you the other day about that guy in Twitter that was telling me over and over again that, combat my empirical evidence, which is we have to fly to this certain height, 4,700 feet or something above this Lake Huron, to communicate to the other side with VHF. And, when I come back to him and told him about, the scattering and the way, and he just couldn't see that. And he kept saying, no, it's because the curvature of the Earth. It has nothing to do with any of the things that you're talking about. I said, no, but look at this says right here over bodies of water that you can have. What is the scattering called?
It's called multipathing.
Thank you, multipathing. And no matter what I said to him, he just could not grasp it because he teaches how to fly planes. So he says, no, that's not right. I teach how to fly planes. We teach them that they have to go up to this height to get over the curve. Like, I understand what you're taught. That's not what I'm saying. I'm saying, is there other possibilities? I'm even showing you another possibility, and you're just declining it because it's not what you teach. But again, this is the problem, that they're just not going to listen to us and ever take what we're saying seriously because they figured it can't possibly be correct.
Well, this is the danger of cogdiss, right? Like, the pride will lead you stumbling into a sentence like, at best case, you falsified the radius, not even realizing the implications of the falsification of the radius. That's why we are here, bro. And if you're an aerospace engineer, you would know, right? To ever attain escape velocity, in theory, you need a radius of orbit, thus necessitating a very accurate radius value, right? So this is the part that blows my mind. Like, cogdiss will put blinders on you so much so you don't even realize the implications of your concessions you were forced into a corner of. Just be honest. It sets you free, bro. You can't have a radius of orbit without a radius of the Earth. You can't attain escape velocity. The model can't work without an accurate R value. It's simple.
An entire model is based on that R value. Take out that one piece and it all comes tumbling down.
Yes, it does. Entirely. Oops. All right. So, like I said, as if that weren't bad enough, he obviously caught a lot of flack, as you can tell by reading in the comments. And there weren't a whole lot of globers in there with any other sound rebuttal other than, oh, yeah, well, you're stupid, and stuff like that.
That's a good one.
Ad homs.
That's solid.
Yeah, that's solid. Absolutely. And, we're flurfs and we're dumb and all that stuff. But, other than that, pretty much. And then he tells people that, oh, we don't allow that kind of stuff in there. Please modify your word. But, he still is allowing the fact that we're Dunning-Kruger and cogdiss, and, it's ridiculous. Even double standard in his comment section. It's beyond belief. So whatever. So we're going to go on now. Obviously, he felt that, after those comments, that he decided he probably better put out a part 2 to smooth out some of the fires that obviously he got his butt into on part 1. And this is where it gets even funnier, right?
Okay, so here's my new advice. When you find yourself in a hole, first thing you got to do is stop digging.
Yeah.
Okay.
Okay. There you have it. All right. So let's go ahead and play this and give it a listen. Here we go.
Episode 2 of Aerospace Crash Course. I'm I Can Science That, and last time we talked about an aircraft flying over the curved surface of the Earth and how it must fly in a curved path in order to do that. We saw that due to the nature of aerodynamics, an aircraft naturally does that by simply following along with a line of constant air density. After that last video, I had planned to get into some of the more fundamental behaviors and fundamentals of aerodynamics so that we could use those to go forward and talk about today's topic with a better understanding of exactly how it works. But after last time's video, there were a lot of people left with a lot of questions, and I felt like maybe it's a better idea to address those immediately in a very overview kind of way, and then we'll go back and fill in those fundamentals that I talked about, and we'll do that math that is necessary for that. But for now, let's start with just an overview of the rotational part of dipping your nose, and we'll do it as just a very high-level overview, no math at all. I'll just talk you through the basics of the principles, and then in a follow-up video, we'll come back and learn how this all works. Last time I showed this diagram where the plane follows the curve. And we talked about how the aerodynamics are such that that naturally happens. However, my airplane in my little diagram here isn't rotating as it follows the curve. I just showed it sort of falling along the curve. Many people pointed out that that plane is at a very strange angle right now, and we really can't leave it like that. So perhaps that is what we mean when we say dipping the nose.
Yeah, and by the way, I wanted to point out the people that pointed that out were the flat earthers. The globe earthers were like, yeah, dude, you had it all the way right, bud. 100%. Yeah, you got it 100%. Yeah, I don't think so. He did get it wrong. This is absurd to even consider this could possibly be right. I mean, this would be halfway up a loop, at this particular angle from a tangent to the ground. Right? It's ridiculous. So really who he's responding to here are the flat earthers, which is interesting. And this is where it gets damn funny. Here we go.
It could mean that that plane has to rotate as it follows the curve. Maybe we already understood that the plane, of course, isn't going to fly off into space like I suggested last time. We understood that's not the issue. The issue is that the plane must rotate as it follows the curve. Absolutely, that's true. Let's take a look at that now. To make this diagram a little more comfortable for us, let me just rotate it up so that the plane is up in the center of the diagram here. I'm just going to do a rotation. All right, and we can see clearly that the plane's nose is pointing up into the sky. It is no longer parallel to the ground below it. And we just can't have the plane pointing its nose up like that. The air will be coming in from the side, and it is an airplane, so it is the air speed, the velocity of the air relative to the plane that creates our lift and drag, and we need that to be more or less level with the plane in order to keep flying the way we want to go. So we need to get that nose down. The plane is going to have to dip the nose.
Oh,
right?
No, you can't say that. You can't say that. That's God. You can't say that.
That was
remember?
the number one point of the last video is don't say dip the nose.
Dip the nose.
I think that was the number one point of the summary from the last video is don't say dip the nose.
That's exactly right. But it's going to have to dip its nose. Well, okay, let's go with it, I guess.
I'm confused. You got me, dude. I'm confused.
Quick tangent right here. Remember last time I said that dipping your nose is an imprecise thing. It's unclear exactly what you mean. And in order to avoid confusion and fighting, be more clear about what you mean. If you mean
if you said to a pilot,
curve,
dip the nose, I think he would know exactly what you meant.
I think
but
so
if you
too.
if you said to a pilot lifty, he might not.
He might not. No, the liftiness of the aircraft he would probably struggle with. But if you said, "Hey, dip the nose," I think he would know how to respond to that. Just a thought.
Yeah, exactly. But we can't use his term because he told us we couldn't. But we'll let him use it and
I don't
make
feel
our
very
case for
lifty
us.
right now about that, Bob. I'm not feeling particularly lifty.
I know. What can I say?
Like we talked about last time, then say following the curve. If you mean rotate to match the curvature of the Earth, then say that. Saying dip your nose is just too vague and not clear, and that is the cause of a lot of this.
Oh, okay.
Whoa.
Well, he says in the chat, didn't you notice the air quotes? No, I don't see air quotes. I see quotes around it, quoting that you said that, and that was a quote. So yes, that is what you said. And not only that, you're going to completely reify this and go back and assert it over and over and over again. So I just don't get you, dude. You tell us not to use it, and then you go on and use it over and over and over again.
Problem. So let's see the plane dipping its nose. The plane has come back to level, and of course that means, yes, it had to dip its nose to get there. So before...
Because introduce negative attitude? Is that what...
Yeah, exactly. Change the pitch down a little bit. Is that what
we're getting to?
And because he used air quotes, does that change the fact that the pitch of the nose came down several degrees. I mean, I don't get it. I just don't. Yeah, I don't even understand what he's saying here.
I do, but again, the issue is not comprehension or even physics here. The issue is I can't be wrong. I have to defend at all costs. It doesn't matter.
Yeah, like that's my diagnosis too. Like this is an honest projection of him trying to work it out in his own mind, right? Like he's not even trying to be deceptive, in my opinion. Like he's literally, this is just him projecting outward his own path of trying to figure out how this has to be, because he has to believe the Earth's a ball, right? Like that's what
exactly. The belief is the Earth's a ball, and he's just trying to explain how that has to be, no matter what, right? And so it's going to flail, and it is. Right? You start gesticulating and flailing, and this is where, you know, if you do the third video, this is where you'd say you go down for the third time, you're going to drown, right? So Bob says do it. I'm going to say I recommend don't. Anyway,
but this
let's continue.
All experiments and tests that these guys do always come out the same way, is because they already have a preconceived notion or an end result that they have to get to, and anything that comes outside of that, they're just going to deny and decline or move past. It's quite obvious, very telling.
Well, the problem with this, guys, is they have never come up with their own evidence of curvature or rotation. Let's review that a little bit. So right now, who is their current reigning go-to guy for a completely fallacious case of Earth curvature? That would be Ranty Flat Earth, right? Because Ranty cut and went to the other side. Now, all of a sudden, all the ballers are backing him up saying, yeah, see, even your guy's saying that this guy's proving it. So here we got a flat earther proving it. Then what do they say about me? They say, well, because Bob in Behind the Curve said we registered a 15 degree per hour rotation, not ever knowing how the rest of that movie came out, right? And what we actually did discover, because of course the ether can't possibly exist, right? Then they have to go to a flat earther and an ex-flat earther. Why? Because they have never, ever, ever one time come up with anything that has ever shown motion or curvature on their ball Earth. They have never been able to validate the R value. We, on the other hand, can falsify it all day long, twice on Tuesday and every other day 10 times. It's absolutely ridiculous. They got nothing, and all they can do is say, yeah, but. And I'm sorry, guys, you got to do a lot better, because you're flailing, and this is just pathetic. So let's continue on.
Before I talk about exactly what makes the plane do that, or how we get the plane to do that, which obviously we must, let's sidetrack things a little bit to talk about just sort of a vocab word that I'm going to be using, stability. Now, in aerodynamics, in engineering in general, stability means the situation where if there's any disturbance in the situation, that will naturally restore itself back to the way it started. So that means it is stable. Something that is stable will correct itself for anything that starts to wobble or shimmy.
So the situation here is that, the situation requires that if there's any disturbance in the situation, then something's going to come along and change that situation to where it doesn't have the disturbance anymore and it's stable. Wow, that made a lot of sense. How about we just go with what I said earlier, dude, and that a flight instructor will tell you that if you ever get in trouble with the aircraft, one of the best things you can simply do is just let go of the controls. It will automatically resume its own level flight itself, unless, of course, you are in some extreme case of a flat spin or something crazy like that. But, under most circumstances, if you're suffering from a little bit of vertigo, vestibular system problems or whatever, if you just let the aircraft controls go, then the situation will be that the aircraft will, in fact, go back to a somewhat straight and level flight. But, this whole situation talk is laughable. And what you're about to talk about here, I don't even get how this applies to it. You're showing a ball on top of a pyramid that's teetering, that's unstable, and then you put that same ball on the inside and show it as stable. What does that have to do with anything, especially in terms of the aircraft? I'm not getting that one at all, but let's hear you out.
And the best way to really illustrate this is just with this classic diagram. On the left, we have a ball sitting at the point of a pyramid. Now, it could be in equilibrium, meaning that the ball can be held in place there. It would take, like a circus performer to, balance, or maybe we could get, Nathan Thompson out here to balance a golf ball for us or something, right?
Good one. Nathan Thompson to balance a golf ball. Wow, that was hilarious.
Yeah, you might crack up the kids in your Magic the Gathering group, but it's kind of falling flat here, bro.
Yeah, totally.
If you just keep it balanced just right, you can keep it there, but it's unstable. And that means any little disturbance, if you blow on it, if you sneeze on your meatball there, it's going to roll down the hill one way or the other. Right? And so that means it's unstable. If a little disturbance comes along, like you sneeze on it, then what will happen is it will move slightly to one side, and when it moves slightly to one side, that's going to cause it to just roll right on down the hill. On the other hand, this situation is a ball wedged down into a little V structure. We've just inverted it. And now that ball is very stable in there. If you sneeze on that, you might jostle the ball a little bit, but it'll settle right back down into the V. If if you're carrying this across the living room floor, you can jiggle that thing all around, and you'd have to knock it really, really hard to get the ball to fly out of that V.
Are we sneezing because we have COVID
the
now?
ball, you can jostle.
Yeah, and I don't quite understand what the hell these flashcards are. They look like
nothing.
As long as the ball,
they look like
you can
tarot
jostle it a lot.
cards
As long as it stays within the
that
V.
have B on them. Shit, I can't catch it fast enough. I'm not even sure what the hell that's about or what the point is.
Oh, he thought he was going to make a little Illuminati joke. He thought it was funny.
Oh, is that what that is? Okay. Yeah. Again.
But see, I thought my joke about Magic the Gathering before you threw those up was more prescient and funny.
I thought it was really.
I agree. All right, let's continue. Oh, thanks for explaining that to me, because I kept looking at that going, what the hell is that supposed to mean? Of course.
Maybe he doesn't play Magic, though. Or never did.
Yeah, could be. I mean, but, you know.
I accept that.
Doubt it.
Because they probably wouldn't let him in. That's pretty bad when you get rejected for Magic the Gathering.
Sorry.
Okay, let's continue.
It is stable, and the ball will naturally settle itself right back where it started. That's what stability means. Let's apply the idea of stability to aerodynamics, particularly to this pitching the nose situation. So we will look at the pitch stability of a typical aircraft. When the nose pitches up, like so, if the aircraft is designed to be stable, then the nose will naturally bring itself right back down. This is a highly desirable situation, and we design for that on purpose. Now, what that means is if the aircraft finds itself nosing up because it's going around the curved line of constant air density, then there's a natural tendency built into the aircraft to cause it to bring that nose right back down so that it is moving in the original direction that was set up.
Au contraire, mon frère, there's a slight pitch up elevation to keep the attitude such that positive lift is always maintained.
That's exactly right. That is exactly right. What's happening here, and he acts like this is some sort of mystery, but when the aircraft finds itself in the nose up position, essentially you're going to be bleeding off airspeed, right? And when that happens, then that variable, that controls the lift is going to be bleeding off, and the nose is naturally going to drop back down, right? So it's not some mystery, effect that's going on here. This is really straightforward aerodynamics. Now, there will be certain planes that respond differently to this, like I said, and like he said, you can have fighters that may not necessarily be so forgiving or docile. Certain planes, these type of configuration of planes tend to be very, very forgiving, right? So,
well, I don't know, man. The thing is like, again, I got 2 more brain cells on a horse, which God gave me so I don't poop when I'm in a parade, and I know this stuff. I don't claim to be an aerospace engineer. I know this stuff. I don't know. Sorry.
Yeah, but anyway, this is just. This is not anything magical at all. Yes, of course, the aircraft is designed to be stable, but when it finds itself in a pitch up position and it's bleeding off airspeed, then that lift coefficient is going to drop and it's going to go nose down in an attempt to regain that airspeed and equalize itself out. It'll kind of dampen out the
glide
wave
path, and that's what it'll find a glide vector, and that's what the nature of the aircraft is.
That is correct.
That's part of its specification. Anyway.
Yep. Very good.
Let's continue. This is like painful now. All right.
Okay, so that's aircraft stability, and we design aircraft to do that on purpose. You might be saying, that sounds really convenient, right? And then we just say, we just designed the aircraft to be stable so that it would follow the curve of the Earth. Actually, no. The curve of the Earth was not a consideration at all.
They designed the aircraft to be stable to hide the curve of the Earth. That's why they did it.
Wait, what did you just say? Did you just say the curvature of the Earth was not at all accounted for?
Yeah, sort of. Let's back it up a little.
He's basically implying that he goes, isn't that convenient that they designed aircraft stability so that it just follows the curvature? No, they designed aircraft stability so it'd be stable so people can fly. There just is no curvature. Sorry.
Exactly.
We just designed the aircraft to be stable so that it would follow the curve of the Earth. Actually, no. The curve of the Earth was not a consideration at all for aircraft stability. It's just a side effect.
There you go.
Oh my God, I'm done, bro. Okay, you're just a zealot. You're just religious.
Yep.
Cool.
It's a side effect. He said it's a side effect.
That's crazy.
Yeah, it gets better. Let's continue.
Aircraft documents that talk about how the aircraft stability and design was built around a flat Earth assumption. We say that in those documents because we know the Earth is not flat, but we don't bother with that calculation because it's not significant for this.
we say that because we know the Earth is not flat, and yet NASA and the U.S. Army and the Air Force and God knows how many other documents we have unearthed that declare all these calculations are done using the math for a flat, non-rotational Earth. Are all, where are the equations for the rotating ball Earth that has the convexity of, a rotundity of 25,900 miles?
Bob, had you listened carefully to his summation, what you would have understood clearly, right? What you would have clearly understood is that this is the nature of what aircraft do. They design them to be stable in flight, and therefore a side effect of flight is simply that it follows the curve of the Earth that they know is there. And so therefore we don't have to even worry about that. In fact, we don't calculate for that because it's not important. Therefore, it just, the summary is it is magic.
Yeah, totally. And he says, I don't need to list assumption for things that are true. No, they're assumptions. You have no proof of curvature, dude. When are you going to get that through your head? There is no proof for the R value. It has been falsified in every way, shape, and form.
And here's the deal, dude. Here's the deal, right? Without even going back and forth, everything that you're trying to present, right? Again, what I said before is every single flight characteristic about the aircraft. If it were right, I'm not even claiming it. I'm just saying if it were flat and stationary and level, every single thing that you would see is exactly the same as it would be now, without any of these, without any of the rigmarole that you got to go to try desperately to explain why it just sort of.
Yeah, so sort of magically.
Go get a Slurpee. Just go get a Slurpee or something. Maybe a Hot Pocket. A pizza
and you
roll.
can actually look at the psychology of it, really, right? Like, so the first people that designed the planes and started flying them, they of course assumed flat, non-rotating surface. That's when we discovered magically you don't have to account for the spin relative to your direction or the dip in your nose, right? Like you don't have to worry about that because they would have died if they did it. And since we know the Earth's a ball, that must mean it's magically accounted for, right? Because we know the Earth's a ball. That's literally where his thinking is, right? So it doesn't.
Well, we know it
really
is
much
what
you
it
can do
has
with
to
that.
be. So
Yes,
so it works.
exactly.
And the fact that it works proves that it's a ball.
Yeah, how
That's
crazy is that?
That's the circuitous logic. The fact that it works at all proves that it's a ball.
Because we assumed it is, because it wouldn't
Absolutely.
work if it.
Dude, you're so smart. That man, you need to go work for NASA. You are rocket science material.
Yeah, it's pretty bad. Let's keep going.
Aspect of the design. It just happens to turn out, since you all have gotten me interested in the idea of flat Earth, I have looked at this and I realize now, oh, hey, look at that. It turns out that aircraft stability just happens to make it follow the curve of the Earth. Why do I make my aircraft stable, you might ask, if it's not for that reason? The reason is because we want the aircraft to be controllable. We want it so that if any little
never guessed.
And let's mind you, of course, because the aircraft, they designed it, with that stability factor in there, and that stability factor is clearly following the z-axis curvature of the Earth, then it also must be following the z-axis terrain features of Earth as well. What's that you say? It's not doing that? How can that be? How can that be? It's ridiculous. Continue.
Little thing comes along and jostles the aircraft, like a little gust of wind, that it doesn't send the thing off into a loop-de-loop, tumbling and falling to the Earth. We want to make sure if a little gust of wind comes along, that maybe the aircraft jostles a bit, but then it settles right back down to that nice level flight that is easily controllable. And well, one example of a disturbance that could occur is if the line of constant pressure you're following is not a straight line. And many times it is not a straight line, right? Storms come along.
Many times?
Yeah, of course, man. You have turbulence.
Yeah, apparently all the time it's not a straight line, right? If it's following curvature of the Earth, then all the time it's not a straight line, not just when there's a storm or winds aloft or shearing or anything like that. According to you, it is all the time, not many times. All
and again,
the time.
And this is, again, what this is I've brought it a couple of times, right? This is far less any sort of study in the actual physics of it, and far more study in the psychology of just being so certain that you just approach it and we get a hand wave dismiss. I can just explain that away. And then, oh, well, maybe I couldn't hand wave it away, but I know it just does. It happens that, and I feel better about it. I now feel better about it. So I don't have to think about that anymore. It's far more study in the psychology of cognitive dissonance than any study in physics.
Indeed. Okay, let's continue.
And you get an updraft, and you'll get what we see it on TV all the time. They call it, TV pilots call it an air pocket. Oh, folks, we just hit an air pocket, and they say that when the plane suddenly just falls out of the sky for a while. What they really hit was probably a downdraft, right? The air is not actually all that stable, and because of that, we want to make sure the aircraft
I thought it was a perfect line.
To allow the pilot.
Yeah. Well,
that was in the last video, right? A perfect line of stability that follows magically.
Exactly. Well,
I'm so confused, man. I guess I am dumb. I just don't know these things.
Well, so in addition to it being 100% of the time an unstable, right, an unstable curvature, right, because it's always following the curvature, right, then there's also air pockets and stuff like that. So now I guess it's 110% unstable. Makes sense.
Pilot to be able to control the thing, and that is built in on purpose into cars, just the same as it's built into aircraft. And it just so happens that's going to dip the nose of the aircraft for you.
So cars compensate for the curvature of the Earth and dip their noses too?
Pretty amazing. I didn't know that.
I didn't know that. That is amazing. Wow. I learned something today.
I did. I was today years old and I learned that they do that.
Yeah. Oh, he's going. Now we're going to summarize this. Here we go.
What we found that a stable aircraft naturally corrects its own angle. That you don't have to do this. The aircraft will do it by itself. And we deliberately design aircraft to be stable. Sometimes high performance fighter jets are designed to be unstable, but in that case we rely on computers to stabilize the aircraft so that the pilot doesn't have
designed to be unstable. They're designed
to do that by himself.
Performance characteristics that give up stability for performance.
Exactly.
You're not an aerospace engineer, dude. I don't know what you are, but you're not an aerospace engineer.
Yes, because that is
funny the word
true.
stable, right? Because it is a table.
That really does cast a huge doubt.
Plane is flat.
Yeah, aeroplane. Yeah.
Well, personally, like he says he has degrees in AE and teaches the undergrad level. Like I wouldn't say that's impossible. I've debated quite a few people with credentials. This is actually kind of what you get. So
well, I don't think he's a working aerospace engineer. It's like I wouldn't fly in his plane for sure. I can see him teaching at undergrad level for sure, because this is exactly what Dunning-Kruger is, right? This is the higher the education, the deeper the indoctrination. You got to defend it, and that's exactly what he's doing. He's trying to do it as an educator, like was it Boyne said in chat, right? It's cognitive innocence, right? Just it's naivety, but intentional, right?
I will say personally, for me, I empathize with people like that. Like personally, yeah. So like. I always try to hold out hope. I don't know. It's possible. Maybe this guy really wants to know. I would say if you put him up to a lie detector test or something, he would admit that he looked into flat earth because one of his friends told him about it, and he realized, wow, there's more to this than I really understood, and this is a crazier conversation than I maybe thought it was. It's definitely not stupid. And now he's just trying to explain some of the things he thinks that he has, an expertise in as to how it doesn't
he's
prove
doing what a bunch of us did in the first 48 hours when we, came up against it. It just, again, there's something about really wanting to go after the truth and not defend what it is you think you know, or defend your ego, in which case, you can kind of get into. But I agree with you, Austin. I have compassion for people, but also I would say, again, for those who are watching who are compelled to that they think they can convince everybody, I would just say, here's an example. It's not everybody's going to be, you have to kind of want to know. Does that mean you should stop trying to tell people? No, look at what Austin's doing, man. He's doing fabulous work, right? Waking people up. You just got to get people to ask the right questions, but they have to ask the questions, right? For themselves.
Yeah,
if you try to answer the question, you're never going to learn. So this would be, again, my advice to our friend here is you're never going to learn anything with your mouth open.
Yeah, that's for damn sure. Absolutely true. Okay, well, let's continue on, get the last few minutes of this and get this out of the way, because, dude, I'm sorry, man, but you have made the worst showing, ever. Hands down. And to come on claiming that you are a aeronautical engineer, maybe you are, but oh my God, the things that you're claiming are so asinine.
I wouldn't admit it.
Oh my God. It's pathetic, straight up. And you know what? I don't give a crap if I convince you or not. Who I'm after are the people that watch this video and to listen to you and watch what you're typing in chat and how you're going to respond on your videos. And believe me, if there's anything worth responding to, we will respond to it. Because, like I said, to me, this is the absolute, you messed up, dude. You should have never, ever, ever walked into this, I wouldn't even say it's a trap, but this beehive, because you're never going to recover from this. You have nothing. You have absolutely nothing that proves your case true. And like I said before, you're going to have to also integrate, not only are you going to have to expand on these explanations, but you're going to have to tell us why every instrument that he's used to measure pitch change, rotation, rigidity in space, anything like this, none of them are picking up any of these motions that you're declaring are there. They just don't. None of them. You've lost. Point blank, but it's
or come to Flattoberfest in October, and I'll make you a cup of coffee.
There you go. That's a nice guy.
Mm-hmm.
All right, let's finish it out.
Does the pilot then need to dip the nose? This comes right back to it again. Is here we've described that following the curve of the Earth will require the aircraft to rotate. Yes, it will. the aircraft's nose has to dip as it goes along the curve. But if you ask a pilot, hey, pilot, are you dipping the nose as you fly? The pilot's going to say no.
Unless you're Wolfie 6020, who unequivocally says yes, that he does. Wrong.
He's going to say no. Why is he going to say no? Well, there's actually a number of reasons why they'll say no. But what we just talked about in this video is that the aircraft dips its own nose. That's just how aircraft do. So the pilot, no, he's not going to need to do that.
This is the guy. Oh my God, this is the guy. This is the guy that turned in the paper wanting to know about the thermos. This is the guy. I knew I recognized him. He's put it. They wanted to know what the best invention of the 20th century was, and his thing was the thermos. Is why? Well, it keeps the hot stuff hot and the cold stuff cold. Well, how do it know? How do it know? This is the guy.
You're going to have to elaborate on that in a little bit.
Okay.
Okay, let's continue.
All right. If the planes just flying themselves, right? And you know, I heard a flight earther ranting about how pilots don't do anything. Let's think about it for a minute. The pilot's the one who decides where the plane is supposed to go, right? If the pilot's decision is to just cruise.
Oh my God. His whole argument has been the plane does this magically on its own without the pilot. And then he says the flat earthers say that. What's happening here?
It's called doublespeak. You're watching it happen. I told you, it's full of it from start to finish.
What's happening?
Yep.
It's a Mandela effect?
At a nice steady altitude. They don't have to do very much about that. The plane is designed to do that for the most part all by itself. And we will definitely set up an altitude hold autopilot to assist with that. Doesn't take much to cruise along at a nice, steady, level altitude. But what about the times that's not what you're doing? You're taking off or you're landing. That's not cruising at a steady altitude. What if you're turning and so forth, right? You don't just point your nose and then walk away. Not a good idea. Not to mention, the air is not always as stable as we've described in these diagrams. There are updrafts, downdrafts, crosswinds, wind shear is what
100% an air curvature. So not that it isn't always, it's never, because you have a 100% curvature plus all those other factors. So, geez, it's a mess up there. God, I'm surprised I'm even alive after flying.
What you call it when you get into a situation where the wind suddenly changes. And that absolutely happens, and we need the pilot to be on top of that. Okay, all of these diagrams, I've shown how the plane will follow along with a nice constant line of constant density. What do you do when that line of constant density starts wigging out on you? Well, you better pray you have a pilot in there who can help you. And finally, I should note, and this is a common theme amongst science topics in general, is that I have skimmed over some details here that
I can definitely agree with. You have massively skimmed over some details. Again, we're going to need answers. The gyroscopes, the accelerometers, why none of these flight instruments ever detect this curvature, motion, acceleration, ever. Why?
I'd go for any large logical argument, even one.
Yep, but you got nothing, and that's
I'd
just
take
the
even
fact.
one logical argument at this point.
Yep, yeah, even one, which they don't even have one, not one.
Maybe if we continue this series and people are interested, we can learn more, and we can find. There'll be a future video where I say, "Hey, remember that slide back then? I skipped over something really important." And maybe we'll come back and we'll learn about more aspects. But for now, I just wanted to cover that the pilot does not have to do anything to correct for this rotation effect, because the aircraft designers made the aircraft stable in the pitch mode. And because of that, the aircraft will level itself as it
continue
flies.
to fly straight and level.
Not
That's right.
something that
It'll level
the
it. It'll
pilot
level
necessarily
itself.
needs to do. Although
It'll level itself on the curve, and the pilots created stabilization features assuming a flat Earth. That's how it magically doesn't have to account for the curvature or rotation. Got
Well,
it.
also, what you're not accounting for is that level is curved.
Oh yeah,
right.
Yeah, damn, I skipped over that.
I know. Yeah.
Be careful, because they really believe that.
I know. That's the scary part, man.
It is scary.
I will say the pilot will be looking at his artificial horizon or at the actual horizon and checking on things and making sure that everything is trimmed out right and flying nice and level like he wants to.
Yep. And his artificial horizon, his rate of climb indicator, none of those instruments will ever register any function coming from the curvature of the Earth or reaction deliberate to compensating for the curvature of the Earth. It just doesn't happen. And, you know, again, you got a lot of splaining to do, buddy, because you are way off in left field.
Okay, so I think
with confidence and gusto. Okay, so I just knocked it out of the park. And this is why I don't play chess with pigeons, right? This is the part where they're flapping their wings and they've knocked the pieces over the board. They flap their wings and they go, "I won."
Yep, and they say that about us all the time.
I know.
It's unbelievable.
View of what stability means and why we would want stability, you might still be left thinking that that was quite magical. My description of stability is just like, oh, it just magically does this. It just naturally does. And I didn't explain how that happens at all. And so you could honestly be curious about how that happens and maybe skeptical about whether I'm just making stuff up here or is there something to back this up. And to that, I will say, yeah. Let's do that in the next video. I plan to start
is there evidence to argue the fact that people design aircraft to be stable? Sure.
What the result is. But after seeing the response to the last video, I decided instead, let's look at the result first. And then in following videos, we'll learn some of the basics, some of the fundamentals about how we make the stability thing work. And actually, it comes out pretty simple. There might be a little bit of math in future videos as we explain how the stability works, but nothing too bad, I would say. Okay, so that's where we're at. See you in the next video.
Or not, because again, first reaction again is, dude, the condescending thing is off the charts, and you think you're gonna like slow it down and talk down to us, and oh, dude, yeah, it's not too difficult, it's not real hard, and at the end, the implications, and this is the direct implication that we would imagine that they don't design a craft to be stable. That's a conspiracy. They wouldn't do that. They're just to design it to be stable. No way. That just can't. Come on, dude. Seriously,
yeah, it's bad. I mean,
the hubris of this is off the charts. And by the way, again, I don't this type of stuff I don't like to do, but a little humility would be nice, right? Like between Bob and I, we're like 4 times older than you are, right? And probably have a little bit of life experience, right? So I don't know, just humility is probably good. Just at this point, I'm just saying.
Yeah, just saying. But anyway. All right,
and so Jeran's smarter than all of us put together, right? So, and then Witsit, he's off the charts. We don't even measure that shit. But he's an alien.
Indeed. All right, okay, guys. Well, there it is. And again, I'm playing this gyroscope video. I put all these videos in the show notes, including Rob Durham's take on this, where he got this very same gyroscope and then put it in his car and drove around with it and did all kinds of tests with it. I'll put that link in the chat as well, or in the show notes as well. Because again, all of these things should be telling us that there should be a curvature there, and they don't. In fact, they tell us the exact opposite. They tell us that there is no curvature there. They tell us that there is no motion there. And your lame-ass excuses of saying that, well, the gimbal stress is too restrictive, and therefore it doesn't have the sensitivity to register 15 degree per hour rotation. or anything like that, even approaching that, is ridiculous. You know, like I said, we can measure accurately, quite accurately, down to a 1.2 degree per hour rotation and have proven it experimentally. And you guys, again, you got nothing. You got nothing. And if you look at the comments, when you guys read the comments in this guy's chat, right, and you can see the ballers in there and how it's just complete Dunning-Kruger. And they say things like, oh, yeah, well, every picture shows it as a ball. It's like, you just don't get it, do you? That even NASA tells us that none of the pictures are legitimate. They are all computer-generated images. Again, you don't even have a picture. You got nothing, okay? So I don't know what else to say. You know, that's that. Globebusters, can you please explain why planes stall? Yeah, I can do that, Scott. Planes stall basically because if you increase a very common stall situation would be if you're flying along and you increase the pitch of the airplane to where the nose is so far up in the air, you basically start causing the airflow over the wing to basically burble, and you're whether it's coming from wind deflection or whether it's coming from Bernoulli effect or whatever. Essentially, what happens is the angle of attack on the aircraft is too high to maintain the flight level or flight pitch angle that it's flying at. And what will happen at that point is the nose will drop, which is the stall condition. And at that point, it will, start flying downhill at a very, substantial rate of speed in an effort to regain its airspeed and thus its flight stability. So, and even that, again, has really nothing to do with this particular subject, but, just to give you a quick answer, that's basically what causes a stall. So,
yeah, the quickest answer is the aircraft loses lift.
Yeah, pretty much. That's the easiest way to put it.
Yeah.
So there you have it.
Just to address this, I hate. Okay, so we falsify the radius. It's like, well, since your observations vary, doesn't that mean that it's the improper way to test it? No, we all know this. It's very simple. The globe Earth has a certain radius, okay? So it has a certain geometric horizon. So the Earth's curvature is a physical, tangible location that has to physically block our view at a certain location based on the size of a sphere, objectively. We go out and make observations, and we see that we have horizons way too far for that radius value to be accurate. One of them, 264,000-mile radius, and it constantly fluctuates day to day, even hour to hour, based on atmospheric conditions and, of course, your observer height. That is what is expected on a flat Earth. The horizon is not a physical location. It's apparent. Of course, it fluctuates. So when it moves, it is evidence of flat Earth. It is no way detrimental to our postulation. That is insanity. Okay.
Well said. Very well said. So, okay. All right, guys. So there you have it. We're done with that. And I think we're going to go ahead and move over to the Rockfin side and let Eru go ahead and talk a little bit about his Elon thing. And then we are going to call it a show because honestly, I'm not feeling that great today. But I did want to get this out there because I did find it fairly humorous and I didn't want this to get away from us. So there you have it. So I am going to go ahead and cut off the YouTube stream now. Guys, again, please consider subscribing to Rockfin. Again, when you subscribe with that $9.99 a month subscription rate, it helps out all the Globebusters. I do send money to Austin for his activism that he's doing. We do share that money between all of us, and it helps all of us to be able to do that. And, it's just greatly appreciated to help us get these messages out. And you guys know how crazy times are getting, right? Not to mention the fact that Rockfin also affords us the platform that is not censored, and we can say basically what we need to say to get the messages out very clearly. So, it would be appreciated, and it would be great if you could, make that subscription and join us on Rockfin. But if not, like I said, if you can't, you truly can't, we understand. And that is why we do the Wednesday night shows for you guys, and we will continue to do them for you guys. But I think that today is the last Sunday show that we will be streaming on YouTube. So there you have it. So guys, on YouTube, we will see you a little bit later, and we'll catch you on Wednesday. And other than that, hopefully we'll see you on Rockfin next week. Peace out, everybody.
Peace.
Peace.
Peace.